Welcome to Lesson 1.1. Be sure to download the associated course files with these lessons. This download contains many useful items, including the sample SQL that I will use to demonstrate many of the features of tuning SQL statements. The sample databases that I'm going to use for this course are also available in this download. You'll want to install those at your site perhaps and reproduce the same results that we're getting in these lessons. There's also many scripts and reports that I'm going to discuss and illustrate throughout the course. You're going to want to use these in your day-to-day use of SQL tuning. We're going to start with the ABC tables. These tables make a nice three-way join. I have some where clauses that go with them. It makes it easy to illustrate how Oracle is processing your SQL statements. It makes it easy when we start working with hints and some of the other features that are available to show how they affect the explain plan. It's an easy three objects to work with. They're small and it's useful for the first part of this course. The masters, managers, and teams we will use throughout the rest of the lessons. This is a public domain database. Easy to install. I've had to enhance the master table with additional rows as computers have gotten faster to keep the SQL that we're going to work with in this course broken and being able to tune it and show results with the techniques that I'm going to discuss. Why do we tune? We want to avoid costly upgrades. I have seen companies do tuning, disk compression, a reorganizing of tables to save on disk purchases. This is kind of yesteryear thinking. Disk has become very huge, very inexpensive. The typical reason I see response tuning is to save on buying faster processors. The upgrades for these additional processors, the software costs can be astronomical. So I have seen companies actually want to utilize the existing hardware better, and to do that you have to tune the application so that it runs faster. I have personally been involved with rehosting Oracle applications to run on cheaper hardware where you don't have the additional software costs. The whole reason for tuning is to make the end users more productive so that people are not waiting for a response from their computer. The part of the response time that we're looking at, there's a lot involved with Oracle response time. We are going to focus on the database time, the time that your SQL statement actually spends on the database. If you look at this graphic, you'll see browser time, you'll see application server time, you'll see the LAN time, okay? The time that it takes to not only submit your request to the database, but to get your results back and your result set back. The other pieces, there's other people involved with those pieces, and end user workstation time. Those are all topics for another course. Watch for those courses to be available from Pearson. A typical transaction uses all the parts of this model. Okay, the workstation initiates a transaction, the network carries it to the web server strips out the SQL statement, sends it to the database server processes the SQL statement, returns a row set to the web server then formats it to the way that the application is requesting it, be it a PC-based application, be it a web-type application. There's also network time associated with each of these parts. What we're tuning here is just the database time, the time that you see in the gray boxes, but just to keep in mind, there's a lot involved with application response time. Okay, who does the tuning? I like to get design and analyst people into these lessons. Nothing beats a good application design. With a good data model, you can identify all of the indexes, and more importantly, and I'm going to talk about this in the indexing part of these lessons, is the design person will have a good handle on which part of the application needs to be the most responsive. Okay, that is important for overall application design. Who is the best person to do the tuning? Probably the programmer. These people not only probably did the coding, but they understand the data. So when they're putting together a SQL statement, they understand how many rows they're expecting from certain types of where clauses and such. So these folks are the best for doing tuning. These lessons are aimed at the programmer. I will provide you with many different ways and things that you can do while you're testing to identify poorly performing SQL statements and do something about them. Everybody thinks it's the DBA's job to do the tuning. Typically, these folks understand the tuning process probably better than anyone else on the staff. They usually get involved if there's a production problem, and part of their task is to monitor for performance bottlenecks. The system administrators are really good if you need additional hardware, disk, more memory perhaps, but from a tuning point of view, it's mostly the programmer and the DBA, and nothing beats a good application design. Okay, how much is enough? Set goals for specific problems. Work with the end user. What is an acceptable response time? If the system is broken, getting it back to where it was is typically the acceptable response time. People need to be realistic. If you're returning tens of millions of rows and the requirement is to have that in sub-second response time, that might be difficult to do. But come up with, from the end user, what is an acceptable response time? And I'm going to talk about this in the very last bullet point here. Evaluate your options. Sometimes additional hardware is the answer. I'm going to come back to this one with a short story. I worked with a fellow that spent great quantities of time talking the end user out of the fact that they were even having a problem. This typically isn't a good solution, but doing nothing at all is sometimes the easiest thing to do, i.e. maybe they are being unrealistic. There are certain issues like batch jobs that did not get done overnight and the users are starting to use the system first thing in the morning, where there's conflicts between the online systems and the batch systems from overnight. We might be able to schedule around those. There's other options. And again, watch for the advanced SQL tuning course available from Pearson. And I'm going to talk a little bit about the purge data. This kind of goes in line with the first bullet point of this evaluate options section. I've been doing tuning as a business and a profession for the past 12 years. One of my first assignments was in eastern Iowa, and those folks wanted me to look at, I believe it was either Cognos or business objects, and they were doing this thing called a data pull, and it would start about 2 in the morning. It had to wait for another job to get done. Needed to be done before 6 a.m. Okay, and it ran for 3.5 hours. As it started to close in on 4 hours, Intel would come out with a faster, quicker PC, so they would rehost the end application that did the pull, did the data prep, on a different PC. That was their solution, was additional hardware, faster hardware. Well, they wanted me to take a look at it, and I wanted to rewrite the data pull so it happened on the server using PL/SQL, reorganize the objects, and then they would just report against something else rather than what they had pulled. Well, they thought that was time consuming. They really didn't want to budget a task. They were looking for an easy solution. So I said, purge some data. Objects with less row counts run faster. Well, you'd think I asked them to chop off their right arm. I was there off and on for about 3 months, and towards the end of my stay, it got back to me that the application was running inside of 2 hours. Okay, they'd cut the runtime down a good third, and they didn't buy another PC to rehost it on, and I asked them what they did, and they smiled and said, we were able to purge some data. So don't overlook options. Sometimes as simple things as purging data will make things get within the acceptable response time. Now going back to acceptable response time, I'm going to talk about the last bullet point here. I have seen DBAs spend a week to reduce the runtime of a SQL statement by a minimal amount. Generally, if you've got a poorly performing SQL statement, and I'm talking about general terms now, you can get 10 times faster, you can get 100 times faster. If you've got something running in 5 minutes, you can get it down to running in 15 seconds. If you've got a task that runs for hours, you can get it to run in minutes perhaps. The point here is you generally get one of those. And once you find that missing index, once you find that poorly coded SQL statement, and you fix and get the faster results, typically you aren't going to get that kind of advancement again. But I have seen people try. I've seen people waste great quantities of time trying. So go back to the original point that I'm making here, acceptable response time. Find out what the acceptable response time is from the end user, and when you get there, quit. Install the solution and go on to your next task. Who is responsible? The person that's responsible for the system is really the best person to tune. It's probably not the DBA, it's probably the programmer or the programmers that are assigned to the task. Nothing beats a good database design. If there's a missing index, the end users are starting to use the application differently than they've used it in the past. Easily could be missing performance enhancements that might be easy to add. Their SQL might need to be reviewed. Some of these SQL generating type tools and I'm not singling any out, but just using business objects, Cognos, those that generate SQL. Sometimes you have to tune around what they generate. Today's computing environment, especially whenever anything is involving the web, they must be performant. These are lessons to help you make that SQL and make that database response time more performant. Root causes, again, can't harp enough on a good design. Really the second bullet point is what I want to point out here. Design around the most performant part of an application, okay? And we're going to talk about this more in the indexing part of these lessons. But designing around the most performant part of the application is very important. Can't harp enough on commit point strategies. Many of the applications, when I'm asked to do consulting, have grown over time. They started out, they were designed to process hundreds of thousands of rows, and now they're processing tens of millions of rows. Things that you program in for hundreds of thousands of rows or even tens of thousands of rows is considerably different for 10 million when you start processing 10 million rows. How does this happen? Your company buys another company, merges in their users, merges in their data. Now you're processing 2 times, 3 times the data. You buy another one, so on and so forth. So commit point strategies on smaller amounts of data is probably pretty good. This is easy for people like me to come along and say, you need to put commits into your code and commit a little bit more often because it's giving Oracle heartburn. It's very difficult to go back and review some of these things. So again, if you can design for larger amounts of data, that's usually a good idea. Developers, poorly coded SQL. We're going to address that in these lessons. Poorly coded applications. We're going to address some of that. Our focus in these lessons are the SQL statements themselves. You are attending the training to come up with better coding practices, utilize various Oracle tools to see what Oracle came up with and how you can improve it, and then understanding the options that you have available to you to improve the SQL performance. To me, the root cause of any application performance issue is a SQL statement or a series of SQL statements. The DBAs are tasked with several things, and there are quite a few items in these lessons that would be applicable to the DBA, including index management. Are the indexes the ones we have being used? As Oracle, the database, improves, Oracle looks harder at which indexes to use and will maybe not be using some indexes. Too many indexes make the evening or the nightly batch job run longer. They make inserts run longer. Okay? So index management is becoming more important. The DBAs well know about statistics management. Oracle 10, Oracle 11, Oracle 12 are the databases that these lessons are primarily focused on. These databases use the cost-based optimizer, and the cost-based optimizer uses statistics to make its decisions. We are going to talk about some of the statistics available, mostly from a SQL statement point of view. And again, watch for the advanced part of this course. I'm going to go into a lot more statistics there. Enforcing SQL standards might be something tasked with the DBA to make sure that the SQL that is coded follows certain standards as far as in clause and or statements and the use of inline views, things that Oracle, the database, likes from a performance point of view. Data management, to make sure that the tables indexes are being accessed and accessed in the correct order. Something that we DBA types used to do a lot was reorganization to cut down on fragmentation. I'm not going to talk very much in this developer's version of SQL tuning on table fragmentation, but I am going to talk about what happens with index fragmentation and the importance of keeping the indexes defragged and in good alignment. The main purpose of a DBA is database recovery and performance, to make sure that if the machine goes down, that when it comes back up, the Oracle database is brought back up in a timely manner, in a safe manner, with a minimal or no loss to data. So that's what the DBA is up to. Okay, managing response times, kind of a wrap-up slide here. If you've got a problem SQL that keeps resurfacing as being a problem, it's helpful to know what you did last time. If you have a tracking system, when you close the ticket, put in a resolution of what you did to fix the problem last time. That might be helpful when you revisit it in a few weeks or a few months if it's a continual problem SQL. These lessons are going to contain some solutions for problem SQL. Keep track of whom or who is having the problem and track the application, the time. Time can be very important. If certain problems are showing up at certain times of the day, again, that's kind of beyond these lessons, and it's topics I'm going to address in the advanced part of this course.